And we are live. As you can see, I have a small update. It's a better camera that autofocuses on my face, so I'm a little bit clearer. You can see all my pimples, nice. So check mark on that. And I would say we continue with the challenge awaited. I'm gonna show that in a second. But first, I have to check that we are online. Yes, we are. Perfect. Alrighty. Then let me share my screen and let's go on. So, last time we already worked on awaited and created a rather complex solution, which was due to a test. But now we can create a much easier one because I made a pull request and that got merged, which removed the test. So we can check that out. That's actually pretty cool. Open source contribution. So if you are interested in how that works, then let me know. I can make a video on that. 2 weeks ago, I explained a little bit this pull request that I want to remove a test case, which is not usual, but it definitely made more sense in this case because the built-in generic awaited has a different behavior now than it had back then. So this removing this test case basically makes more sense since it's closer to the original behavior. I would say we just solve this challenge again. So challenge number 189, easy awaited. If we have a type which is wrapped, which is a wrap type like promise, how can we get the type which is example? If we have promise example type, how to get example type? Let's check it out in code. As always, we start with the test type that uses our type on, let's start with X here. This obviously is now any, but we want it to be the type that is inside the promise. So this should return string for X. And the way to go here is to check if T extends promise like, which is a built-in type, built-in generic, to basically include normal promises and objects that have the then property, which is exactly defined as the promise then property with unfulfilled and unrejected and so on. So we use this built in and then we infer, let's call it value, which will so with infer value we pick the internal value of the promise like object and then we can return the value if that fits. Otherwise we have to call my awaited again with value. That doesn't make sense. Yeah. So we have what we want is we wanna be able to unwrap multiple promises, as we can see here in Z and Z1. So for that we definitely need a recursive solution. And that means let's do it the other way around. So if T extends a promise like infer value, then we should call again my awaited with value. and otherwise we return t. Does that already fit? String seems to work. Y seems also to work. Okay, let's go with the z1 immediately. That is in the end also string or boolean, so this works. And let's check again t. T is number, which is exactly the type here, the that gets passed to unfulfilled in the function. So this is the much easier solution. I'm going to explain it again. So T extends promise like, which is this built-in generic that we can use to not only check for promises, but also for objects that provide this then property, like a promise. Then we can infer the value or the type of the value. Yeah, let's call it value type maybe. No, value. So we can infer the value, and if T extends a promise like thing, then we call this function again. So basically every time this is still a promise, alright, call it again, unwrap one more layer. And in the end, if T does not extend a promise like thing, then it's a normal type, so we can just return T. And I would say now we look at the online solutions. For that, we check it out here. I'm going for the first English one, and now you can see the much more complex solutions. First of all, basically you have to define your own type, which is this promise-like thing that defines unfulfilled. I don't know if back then, almost 2 years ago, this built-in type was already available, the promise-like type, but here you have to say then, okay, T is definitely a thenable or a promise, and then you check, okay, does it extend a promise? Then you get the inner, and if the inner one is actually a promise, then you call it again, otherwise you return inner. If this doesn't extend a promise, then you check, okay, does it then extend a thenable? Then you infer the inner one of the thenable. If it does, then you return the inner one, otherwise you return false. So I posted the updated solution here when I did my pull request. So this is a much easier solution now. I would say this one is done. Also not too hard. Let's go on to the next one. And the next one is... No, wait, let's do it here. The next one is... Here, view it on GitHub. This was what I was looking for. The next one is number 268, if. Implement the utility type if that takes arguments C, T, and F, which accepts condition C, a truthy value T, a falsy value F. C is expected to be either true or false, while T and F can be any type. Here are examples. If true, then A, false B, expected to be A. If false, then A, false B, expected to be B. Okay, that's quite clear. I would say we check it out in the code. First of all, we write our test type that takes an if, and we just copy this here. Oops, there's the T of the true missing. So this is quite an easy one, I guess at least, but I still like to have my test type, which now returns any. And I would start with saying, okay, this condition extends Boolean because it has to be true or false. That's what the exercise basically stated. Then we check C extends true, then T, otherwise F. That would be my solution. And the way you saw all the errors immediately vanished is already a good sign. So with true, this returns A. With false, this returns B. That's great. Let's check the test cases. Okay, this is exactly the one we just tested. Returns 2. That's great. The error one apparently also throws an error. So I would say that's a super easy one. It was quickly done. And now let's check out other online solutions. English one. If with the parameter C extends Boolean, that's nice. TF, C extends true, TF, alright, is exactly what we did. Here someone says this answer would result in B for type error. Okay. It's not valid syntactically, so I guess we can ignore that. Right. Next one. That was definitely very easy. Next one is easy concat. Let's check it out on GitHub. We have here number 533. I don't know how the numbers get that high that quickly, but whatever. Easy concat. Implement the JavaScript array.concat function in the type system. A type takes 2 arguments. The output should be a new array that includes input in LTR order. I guess this is left to right. For example, type result equals concat array1 and array2. Expected to be array1, 2, alright. Let's first go over the mdn concat method. So what this does is it takes 2 arrays and concats the second array, so the parameter that you put into the function, to the first array on which you call the function. So basically all values of the second array get appended at the end of the first array. Now let's check it out in code. So we have here again our test type concat. Yeah, I'm just gonna copy this here, and it should then be 1, 2, 3, 4 all in one array, but right now it's any. Let's check again the exercise. Takes the 2 arguments. The output should be a new array that includes inputs in left to right order. I don't know if the inputs have to be arrays, but I would think so. Let's try it. Extends any array and extends also any array. So basically what we just have to check is u extends array with ... infer rest, or let's call it infer second, because we're getting the values of the second array here. If that's the case, then we return a tuple with t. Oh, can I spread t even? I don't even know. Let's try this. T and second. If that is not the case, then this should be never, I guess. Alrighty. The first test is 1, 2, 3, 4. Looks pretty good, but I see already here a test that is red. A red test, that's what I wanted to say. Tuple as const. Type false does not satisfy the constraint true. Okay, apparently this does not type of tuple. Let's check what type of tuple even is. First of all, type of tuple. Read only 1. what happens if we put in here the read-only constraint? Nothing. Okay, then let's leave that out. By the way, if you're asking why any and not unknown, it doesn't make a difference. At least here. And you have to kind of watch out where you use any or unknown. Oops, kicked the camera. Sorry about that. You have to watch out where you use any and where unknown. You can basically always, if you're not sure, take unknown. That's the thing kind of to say. But here, where you just constrain the parameters of a generic, it's definitely the same to use any or unknown, because you're not really assigning the any to anything, to any variable. So you're just saying, okay, you can be an array of whatever, and obviously it's fine if that's any. But you're not saying suddenly, okay, let's use any here, which breaks the entire type system because it cascades everywhere. Okay, type of tuple does not work. Type false does not satisfy the constraint true. What does that even mean? Type read only does not satisfy the constraint unknown array. Is read only? Okay, I thought what it says here, type read only, one array is read only and cannot be assigned to a mutable type unknown. But I thought that didn't do anything. Type false does not satisfy the constraint true. I don't even know what that means. Okay, let's just Google that. TypeScript type, no wait, what was it? Constraint false. Type false does not satisfy constraint true. This one is tricky. I try my best to explain what happens. TypeScript does not fully evaluate generics until it has to for performance reason. Get fetch object only consists of generics that could be anything, so the compiler doesn't evaluate yet. This would be different if you already put in some real types like you did with type fetch object equals true. The problem now arises when you want to set the default value of fetch to false, because get fetch object isn't fully evaluated yet. The compiler doesn't know that the expression extends true, boolean, false can only be boolean, and never and whatever the compiler thinks get fetch object would evaluate, so we know for sure it's not boolean. The solution to this problem is to either force the compiler to believe the expression can only be boolean, or to move the expression to a point where it has to be fully evaluated. The best way I see to solve this problem is to move the evaluation to the function result like this. That is a very complex answer. Okay, let's think this through on our own. Type false does not satisfy the constraint true. So we're checking here. Does you extend an array with at least one element? Or do we have to check? Let's check for an empty array. No, that doesn't make sense. I mean, the empty arrays work with this. Oops. I would say restart TypeScript server. but obviously it stays. Type false. Okay, that's just the error message of the test. So what do we get here? Never. Okay, because somehow this doesn't, probably because it has to extend read only. Now we got it. Okay, because why is it like that? Basically, we have to check is this a read-only array, because otherwise it does not match read-only arrays. To make sure that we do not mutate it. So let's put in here, yeah, no, we just did that. Okay, all the tests pass now, and I would say we check out the online solutions. Okay, let's put this here to unknown as well, because it's better to have it similar. Okay, yeah, read only has to stay there, good to know. But let's check out the solutions. English. Type tuple, read only unknown array. Extends tuple, okay. Oh, that's easy. Wow, okay, let's reconsider this. So, since we already constrain at the input that both of them, okay, we consider already, when looking at the concat, we constrain already the inputs t and u to tuples, aka read-only unknown arrays. That means we don't have to check it again. That means we can simply return an array where we spread both arrays, which makes absolute sense. I just thought I have to do this to get the access to the values, but obviously I don't. I mean, I did it correctly with t, so we can do this immediately with u. And then we have here a much cleaner working solution. Great. Let's check this out. Do we see anything else? Read only is also read only. Okay, I would say we're good. Next one, easy includes. Let's slowly close this. Oh yeah, a lot of tests. But first, let's check out the exercise. Includes. Number 898, easy includes. Implement the JavaScript array.includes function in the type system. A type takes the two arguments. The output should be a Boolean, true or false. Alright. First, let's discuss again array.includes, which is you have an array and you check if it includes a value. So if the value is inside the array, you get true, otherwise you get false. I mean, it's probably obvious. So let's check it out in the code. First of all, type test equals includes, and I'm gonna just steal some value here. Okay, we got our test type that says any. We already have here a constraint. That's nice. So t is a read-only any array, and u is apparently whatever. And now we have to check basically, is u the first value? Is u the second value? So I would say we do t of number, which gives us immediately the union. Let's check it here, the union of the values, and then extends u true, false. Okay, we got some tests to pass, but not all of them. This is false, which is correct, but let's check for cars. Also false, so this does not work. Does it work the other way around? Yeah, I'm an idiot. I was the wrong way, because we are checking here, okay, is this value assignable to the union in T? Okay. Now some more tests pass, and we definitely get here the correct result for strings, for numbers, for some other things like booleans and numbers mixed. But I would now go and check out the next thing. So we have an array with an empty object, and we check if it includes an object that is a, and it says true, which is obviously wrong. Let's check out why though. I'm gonna comment this out quickly and just put in t number. What's the union of this empty object? This returns true because the object type is basically the parent type of all objects. That means this one is the parent type of this one, so this is assignable to that. We can also check it out here in JavaScript const test, and this is an object, and we now put this value here, and it works, no type error, because this is assignable. Then I would say we use union distribution to check each value individually. And we do that by extending unknown. Then we have here every time t number, and we can check if t number extends u. Sorry, I have to format this a bit better. Yeah, u, then true, otherwise false. This works now. Great. It works now perfectly for the it works exactly for the ones that didn't work before. Funny. Oh no, it works for all of them that are false, because it's apparently never true. If we turn this around, u extends t number. By the way, I have to put on the chat. Anybody write anything? Nope. No, okay, this didn't work. The only other idea I have is to check in both directions. So let's say we check first we check if U extends T number. So is it part of the union, which works? I'm gonna start with that. Which works for all the primitive types, union, true, false. So okay, if this is part of the union, then give me true, otherwise false, which doesn't work for the object or other cases. So for example, here it also doesn't work because false is obviously assignable to Boolean. So every time you check for a type towards a wider type, then it doesn't work anymore. So if we put in here string, this also fails now. So now, to circumvent that, we check if also T of number extends U. And if that is the case, then true, otherwise false. Okay, now it's all the time false. Okay, I have to check again how to distribute over a union. Distribute TypeScript. Distribute union. Intersection types, no, that's not it. Handbook, type manipulation, conditional types, distributive conditional types, that's it. We've been here before. If we plug a union type into to array, okay, but we don't. We get the we basically pull out the union with T number. How do we now get each value individually? TypeScript force force distribute over union. So, okay, if I read it correctly, we can do T of number, gives us the union, extends infer value. Let's check that. Return value. Which is completely wrong, but it's fine for me. I wanna check it again with this type. Okay, we get the union back apparently because so now we have a single value, and if this value extends U, then it's true, otherwise false. That's still not it because it's always false. I have to think a bit about this. Execute program. Okay, we can prevent distribution of a union U by wrapping it in a data structure, and that's what we learned last time. And we distribute over a union by extending with unknown. Extends unknown. Conditional types. I really don't know. Let's think about it again. So T extends read-only any array, and U. I'm not giving up. We're going to a solution only after we found one. A thing I know we could do is we can basically map over the union. So we have T number. T of number extends unknown, which forces the distribution of the union. If that is true, we can do something with t. Ah, no, with t number. I don't know if it works like that. Otherwise, never. And type do would then take t and u and just checks t extends u. Then you also check u extends t. Then true. Oh, sorry about that. Otherwise everything is false. Type false, so now everything is false again. Hard. Definitely harder than I thought. Okay. I think I'm overthinking this, so we start with any. Then let's start with t number. We get the union of all the values. I really don't know. Okay, wait, let's think about that. Maybe we have to work with extract or exclude, because then we can work with the unions better. Never extends any type. I don't know, I'm not really getting So if we use T number, we have a union, but we have this union inline. Maybe this is also a trap. No, we do get an array. Okay, what I would do now is I would write a second type called actual includes as a workaround. We take T and U. I don't know why he always thinks T is text decoder. T and U. And we basically just use here actual includes and put in there T number, because that's all we need, and U. Now we get the union. So we can check T, we get the naked union, which means it distributes. So we check one by one. T extends U. If yes, does U extend T? Or also text decoder. If yes, then true. If no, then false. False, false. T number extends U, U extends T number, true, false, false, false. Das stimmt doch. That's wrong. So now everything is false again. Alright, I honestly do not know. And that was an easy challenge. It's not that easy for me. I would say we skip this one for now and go to the next one. Easy push. Number 3057. Easy push. Implement the generic version of array push. You get one array and another value, and basically that value gets appended to the array. Array push is exactly that. You have an array and you push one value to the end of the array. As always, we go with type test equals push of 1 to 3. Should be any, is any. And now we're gonna, I would say we do here already extends any array, read only unknown array to do it clean, and U can be anything. So we have T and U. That was now again very easy. All the tests pass. I would say we take a look at online solutions. Push T extends unknown array, U. Spread over T and put in U. Yeah, I would say that was really easy. Next one, unshift. Let's check it out. number 3060 easy unshift. Implement the type version of array unshift. Unshift is you basically add an element to the beginning of the array. Okay, that's after you did push, it's completely easy. We are not even gonna write a test type because it's too easy. So you just return u and t and all the tests pass. So we have here, what we do is we put into a tuple the u and then everything that's already in t. So obviously u is always the first value and then comes the rest of the already existing array. Let's check out the solutions. Unshift t extends unknown array u t. Okay, that was really easy. We give a like. I would say next one, easy parameters. Okay, sounds interesting. Challenge 3312. Easy parameters. Implement the built-in parameters generic without using it. For example, you are given a function. Function params type is my parameters type of foo. Alright. So here we definitely do again our test type. Test equals, and I'm gonna just do parameters here now to parameters to see how it works. Type of foo. So this gives you an array, a tuple of all the arguments of a function. So arg1 is string, arg2 is number. Let's do bar, which is arg1 is boolean and arg2 is an object with a and a. So my parameters t extends So what I would now do is check again t extends this function type args, and then we put here infer params, which we can't do. Type expected. Apparently we can't use. No, we probably can. And then if that is true, we return params. Otherwise, false. Okay, first of all, we do any. Alright, let's check this out. Test is exactly what we had before, and we're using my parameters. And it looks like all the test cases pass, so also this one is really easy. And what we did here is we checked, does t extend a function type, and we inferred the type of the argument array. With ... args, we kind of collect all the arguments together in an array, and then we let TypeScript infer the type of the array. And that's what we return if it is that type, otherwise we return false. I don't know if that was... I don't know if that's what they wanted or if this should be never, but I think it doesn't really matter because there's no test case testing that. Let's check out solutions. Parameters, English, my parameters. T extends, okay, that's what was given. Check again, t extends, infer s, Okay, if that's the case, then return as any. Okay, that's exactly our solution. This unknown int for you. Okay, I mean any int for s. This is just the name of the variable. I mean, it doesn't make sense to params extends unknown array any. Okay, unknown. Yeah, okay, I mean, you can call it whatever you want, but I think args makes a lot of sense because it's kind of customary. Anything else we have here? No. Let's leave a like, and then we are done. I'm gonna take a short break. I'll be back in a second. See you later. Okay, I am back. Maybe I should move less so the camera can actually focus on my face. I think we are done with the easy category, except for the includes, but I'm gonna leave that for the next stream because apparently I have to sharpen my skills a little bit, even though I have to say I think I just have a mental block in that challenge because everything else was, for example, the easy push or easy unshift, everything else was so easy in comparison to the easy includes. That's why we're gonna leave that for now, and we're gonna start with medium. We're gonna start with medium. Oh, that's exciting. First medium challenge. Nice. Number 2. Medium return type. Implement the built-in return type T generic without using it. For example, given a function, the return type of the type of the function should be 1 or 2. I would say, let's get to it in the code. Type test, as always, is my return type of type of fn1. My return type. Here, okay, let's start with this one. Just a simple function. I would basically do the same we did before. Does this extend a function that takes any number of args unknown array, and we infer the return type. And if this is exactly that, then we return the return type, and otherwise we return false. Type false does not satisfy the constraint true. Okay, we had that before with something that had to do with mutability. Let's check this out though. It works for string. Now we're gonna take this one. My return type of fn. Okay. Type of fn. We get false because apparently this function does not. What do I have to do? Dot dot dot. This function apparently does not fall into this category, and I am not sure why. Let's check type test2 type of fn. Type of fn. Which is v boolean returns 1 or 2. Okay, I thought that would be exactly this. Let's see if we can fix this by constraining it to a function. 9. Okay, takes any number of args. That's an unknown array. And returns any unknown, also spell it correctly, type v boolean does not satisfy the constraint. Okay, now we get this has to be any array. Alright, okay. Let's rewind so I can explain it a little bit better. So we see here type v boolean returns 1 or 2 does not satisfy the constraints args unknown array returns any. Types of parameters v and args are incompatible. Type unknown is not assignable to type boolean, which makes sense. You cannot assign unknown to anything because it's the ultimate supertype and all types are included in it, so every other type is basically smaller. It's a smaller set. Wait, let me check if the camera still runs. Oh, I didn't even share my screen. That's not so smart. Not so smart. Okay, I'm basically doing everything here, undo everything. Okay, that's a bit faster. I can keep the test type any, and let's check out the challenge again. Number 2, medium return type. No, fuck the medium. Number 2, get return type. Implement the built-in return type tgeneric without using it. For example, there's some function type and the return type should be basically whatever this function could possibly return. Let's check it out. I was an idiot and already solved the challenge while not sharing my screen, but I'm gonna do it now and walk you through it. And also through the mistake I made, so we get the learnings. So first I'm gonna do the wrong solution. We're gonna check, does t extend a function that takes any number oops, of arguments, and now we infer the return type. If that's the case, we return the return type. If not, false. So now we see test, for example, works and gives us string. It works with everything except for type of function 1 and type of function 2. Type of function 1 does not give us an error, just says false. So apparently this function here does not extend this type. And to understand why, I'm gonna say it has to extend exactly this. And now we get a better error message. We can see here the type function with two parameters v and w returns 1 or 2 does not satisfy the constraint ... args unknown array. Types of parameters v and args are incompatible. The type unknown is not assignable to type boolean, which makes sense because unknown is the ultimate supertype. So it cannot be assigned to anything except for unknown. And here we have something that is called, I don't know what it is called, to be honest. There are two positions where types can live, and that is basically one. I have to look that up. Give me a second. I think it's covariant and contravariant. Let me check that. Keyword covariant type parameter. And I'm gonna just go with variant, covariant. Okay, so a covariant type parameter is a value we provide, which is basically just a normal value. Think of a covariant type parameter, every normal type parameter you know, but then there's a contravariant type parameter, and this is exactly what this is. So it's not a value we provide, it's basically a value we receive. That means yeah, I think if we put here never array, it works. Unknown is not assignable to type boolean. Ah, wait, here, never. And this is the crazy thing. In a contravariant position where we basically consume a value and do not provide it, we receive the value and we consume it, like here, never and unknown, it's exactly the opposite. So basically everything is assignable to never and nothing is assignable to unknown. That is why we got this error here. Oh, obviously we still need t. That's why we got the error here with unknown. So with unknown, no, let me restore that for a second. If we put here unknown, then it says here unknown is not assignable to type boolean. So basically we are assigning this type to the other type. So obviously never, which is assignable to every type because it's the empty set, is working with all types in this position. And this is a contravariant position. Now we don't really need this constraint, so I'm gonna remove it. And here we can put either any array, because every type is assignable to any, and any is assignable to every type. That's why any works. It's basically the cheat code. Or we can, instead of unknown, we can do never, which is the unknown in the contravariant position. It's the opposite. Okay, all tests are passing now. We get here the correct value. I would say let's check out the solutions, and I'm curious if anybody talked about that. Okay, type my return type T extends function. Not really necessary. T extends a function with any infer R or never. Okay, you can put any or any array. It's obviously, it doesn't matter. I'm curious if I put here now never, it should still work because it's still everything. Yeah, here somebody also has never. Okay. According to the newest versions of TypeScript, you better use unknown or never. By the way, toggle night shift. That is much better. According to the newest versions of TypeScript, you better use unknown or never instead of any now. And you better don't use function in such cases because function also means a class, which may be misleading. So my recommendation on this code, T extends args never unknown. Okay, you don't need that, but it's a good constraint to have. And T extends exactly what we have, infer R, return R. This fails. Here, need to use never array instead of unknown array for the parameters type since the assignability of the parameters type is flipped, i.e. never array behaves like the top type here. That's exactly what I also said. Okay, thank you for tuning in. 4 views. I have to watch that a little bit more so I can interact with viewers when they're actually there. But I mean, 4 views is infinitely better than 0. So thank you for tuning in, and I think we got a bit forward. Next time definitely doing the includes challenge, and I hope I can remove this knot in my head. And until then, yeah, thank you. If you learned anything or had fun, just like and subscribe, and see you in the next one.